How many of our diseases are caused by bad genes? Is cancer a disease of our genes? Which genes cause cancer? We will try to answer these and similar questions in today's episode of the series Secrets of Genes, in which I welcome you. My name is Eduard Kejnobski, and I work as a geneticist at the Institute of Biophysics of the Czech Academy of Sciences. Francis Collins, an American physician and geneticist who led the International Human Genome Project, says that there is almost no disease in which heredity does not play some role. In layman's terms, a disease is a condition where something in the body goes wrong and deviates from normal. And why shouldn't genes play some role here when they are otherwise involved in shaping and developing a person? Each of us was born with dozens of genetic defects. No one is perfect. We also carry faulty genes within us, and no genome is immune to the havoc caused by mutations. Our genome is like it's been peppered with pellets from a shotgun blast. It's just that for each person, the marks show up differently. For some, it's more noticeable, for others, less so. More than 6,000 diseases and health conditions are caused by inherited faulty genes, and today treatment exists for about a tenth of them. Many metabolic disorders have a genetic origin. Genetics initially focused on rare diseases, and in the case of hereditary illnesses caused by a single causal gene, such as cystic fibrosis, the work was relatively straightforward. With many mental disorders, however, the situation is different. For example, in the case of bipolar disorder or schizophrenia, where many genes are involved, the situation is much more complex. Scientists are now intensively studying the molecular basis of diseases such as cancer, diabetes, autism, and many others. There is also psychiatric genetics, which searches for the genetic basis of the most severe mental illnesses, such as bipolar disorder, schizophrenia, or Alzheimer's disease. Is it always possible to distinguish which health issues we inherited from our father and which from our mother? Often, yes. Interestingly, children inherit certain issues from their father, for example, dental problems, specifically crowded teeth, which leads to plaque buildup and a higher risk of cavities. In 2012, scientists from Leicester discovered that a certain form of a gene on the male Y chromosome increases the likelihood of heart failure. If a man affected in this way fathers a son, it is clear that he will pass this gene on to him along with the Y chromosome. In some cases, fathers thus pass health problems on to their sons. From a carrier mother, sons can inherit, for example, hemophilia. Recently, there has been a lot of talk about the heredity of certain malignant tumors. The topic of predispositions to cancer is particularly well developed. Cancer is caused by mutations in specific genes, arises from uncontrolled cell division, and leads to unregulated growth. These changes are promoted by nicotine and radiation. However, some types of tumors are caused by just a single damaged gene, which may possibly be replaced in the future. We can talk about cancer as a disease of our genes. Cancer is actually an imprecise term. The correct term should be neoplastic diseases. We have about 200 different so-called cancers. It is a disease of our genes and is also caused by various mutations in our DNA. These mutations can either be inherited, meaning they are found in the germline of the so-called Dawkinsian River of Paradise, which flows through all generations from the origin of life on Earth or elsewhere up to the present day, or they are mutations acquired during one's lifetime. These are the ones that arose in the cells of our body. One day, together with our body, they will be laid to rest in a coffin and therefore have no effect on future generations. Cancer is caused by mutations in our DNA. Let's take a look at which genes these mutations occur in. The genes that mutate are divided into two groups. First, there are the so-called proto-oncogenes, which are genes that play a role in cell division and simply malfunction. We could compare them to a stuck gas pedal in a car. The car accelerates wildly until it crashes somewhere. A mutation in a proto-oncogene thus leads to uncontrolled cell division. The second group consists of so-called tumor suppressor genes, which I would compare to a stuck brake pedal in a car. The car can't be stopped and also crashes. These are genes that, on the contrary, protect the cell from uncontrolled division and ensure that, in the event of some genetic accident, they direct it toward programmed cell death or apoptosis. That's the car's brake. This group includes in particular the well-known tumor suppressor gene p53, called the guardian of the genome, which is mutated, that is damaged, in about half of all tumors. This gene is quite large, occupying a long segment of DNA, and its various mutations in different locations are associated with different types of cancer. If we know which mutation it is and in which part of the gene it occurred, we can use this knowledge to benefit the patient and choose the most appropriate treatment. Carriers of different mutations respond to treatment differently. It's no coincidence that the discovery of p53 was awarded the Nobel Prize. A well-known mutation is also found in the BRCA1 gene, which causes women with this mutation to have up to an 80% chance of developing breast and ovarian cancer. That's all for today. We've talked about a few interesting facts from the field of genetics of hereditary diseases. In the next episode, we'll continue with this topic. This time, we'll focus on hemophilia. I'm looking forward to seeing you. If you enjoy my stories, I'd appreciate a like and a subscription to my channel. I really appreciate your support. Thank you and bye bye.